Hi guys, welcome to your first video notes. We're going to start off looking at quadratic functions. If you'll remember a couple years ago in Algebra 1 you learned about quadratic functions. Remember that they make a parabola when you graph them. And how do we know when we have a quadratic function? That's when your exponent is a 2. Okay, so let's fill in the table first of all. And let's go ahead and fill in some negatives and some positive numbers. So let's do -1, 0, 1, and 2. So inputting our numbers into the function, we have -1 squared, 0 squared, 1 squared, and 2 squared. Okay, notice the symmetry. Notice that here is our vertex in the middle, and then we have 1 and 1, and then this would be 4, and then if we did -2 on the other end, we'd also get 4. Notice the symmetry. Okay, graphing it, we have a point, our vertex at 0, 0, 1, 1, so I just plotted those 4 points, 5 points right here. So this is known as the parent function. Okay. So what we're going to do is we're going to look at how to transform it. In other words, how to move it left and right, up and down on the graph. Okay. Graphing each of the following quadratic functions on the calculator. Explain how it is different from the parent function in the lines below. Okay, so we have a negative out in front. So what a negative does is it reflects the parabola over the x-axis. Okay, this parabola is opening up. Okay, it's a U and it opens up. Okay, here's the opening on the top. So when you have a negative on the front, we're going to get a similar shape, but this parent is going to be opening down. So we're going to use the same points, but we're going to apply a negative to the outputs. So when we plug in these in, we're going to get these numbers here, but we're going to multiply by a -1. So it's going to cause all our y values, okay, to change sign, except for 0, because 0 is neither positive nor negative. So we're going to have 0, 0, and if we input a 1, we get 1 squared, which is 1, times -1, which is -1. So when we input a 1, we get a -1. When we input a 2, 2 squared is 4. 4 times -1 is -4. So do you see how it opens down? And yes, if you have a calculator, you can plug it in and see that in your table. Okay? So let's see what is happening here. Well, the first thing we want to do here is we want to factor out a 2 out of here. Okay? So when you're working inside the parentheses here, we're going to factor out a 2. And actually, let's just use our calculator for right now, and we'll talk about that in another video. Okay? So plugging this in, there's bugs everywhere, crawling all over. You see bugs crawling on my paper? Don't panic. Okay? This is not live. There are no bugs in your room right now. Anyway. Okay, so I had to pause the video there. Student was confused about where he's supposed to be. Anyway, so we have 2x minus 6 square, and I'm going to go ahead and go to our table and find my my vertex. Notice here, remember what I said earlier about the symmetry? You can always find your vertex, okay, if it's nice and neat like this, See how you get the 4 and the 4, and the 16 and the 16, and the 36 and the 36. It's symmetrical. And then the point in the middle is your vertex. So we got 3, 0. Okay, 2, 4. And we have 4, 4. Reading these off from our calculator. Okay, so we're going to go ahead and sketch that graph. And what we have here is we have a translation. It's translated 1, 2, 3 units to the right. So we would write, because remember, the question here is how is it different from the parent function? Okay, notice in the parent, the vertex is at 0, 0. So it's different because it has been translated over to the right 3 units. So translated 3 units right. Okay. How else is it different? If you look at your parent and you look at your new one, okay, notice the parabola appears to be a little bit narrower than the original, okay, a little bit narrower. So for right now, we're just going to say that it's narrower okay, and we'll talk about a better way of writing that. Right now, we're just doing a little observation on how the parent changes. Okay, so turn the page. All right, so here we go. All right, so here we have the parent, and we're adding 2 to the parent. So again, if we plug that into our calculator, you may want to put the parent in and then put in the transformed equation. That might help you, so you don't have to turn back and forth. Okay? All right, so there's your parent, and there's the transformed graph. So notice, what's the observation? What do you notice? Well, you should have noticed that the vertex has been translated 1, 2 units up. And you can see that in the equation, 2 units up. So the vertex has been translated two units up. And that's about it. Notice the parabola is the same, but it has been translated 2 units up. All right, so if we take that vertex and we move it up 1, 2, and then we can just use the same points that we had on the original table for the parabola. Notice from the vertex we went over 1, up 1. We went over 2, up 4. So from our new vertex, we go over 1, up 1, over 2, up 4. And it's symmetrical, so you can easily 2, 2. Parabolas are symmetrical. In this case, the y-axis is your line of symmetry. Okay. All right, let's take a look at number 5. And we'll plug that one in. If you don't have a graphing calculator at home, but you do have access to the internet, there's a website called Desmos. that works really nice for graphing. Desmos, let me write that down here. Check it out. Graphing calculator. All right, let's graph it and see. So we're comparing the parent, all right, to the transformed. Notice that the vertex didn't move, but the parabola got narrower, okay? Narrower. So narrower for now. All right, number 6. I'm going to let you do this one. Again, if you don't have a graphing calculator, go ahead and try Desmos on the internet and use that. I think that's it for notes tonight. We'll see you guys tomorrow in class. Hope you're having a good night. Oh, by the way, my favorite soda is Mountain Dew.